All right, my friends, are you ready to train the Apriori model on the whole dataset? Well, I bet you are, because indeed we actually did the most difficult part. The most difficult part was to make that transactions list containing all the different transactions of our dataset, the 7,501 transactions. We all put them into this transactions list with strings for each of the products, and this transactions list will be the input of the Apriori function, which we'll use right now to train the Apriori model on this dataset. And so that's what I'm talking about. Most of the job is done, because now the only thing that we have to do is just call this Apriori function from this Apriori package, which we installed in the first cell, and call that function with some relevant values of the parameters. And that will be most of the reflection we'll have when building and training this Apriori model. All right, are you ready? Let's do this. Let's create a new code cell. So the first thing to do will be to import effectively that Apriori function, because so far, make sure to understand that we only installed the Apriori package, but we haven't imported anything. The only libraries we imported were NumPy, Matplotlib, and Pandas. So now we need indeed to upload this Apriori function. And this Apriori function belongs to the Apriori package, which we installed first. Therefore, we need to start from that Apriori package. There you go, from which we import that Apriori function. All right, there we go again, Apriori. And now we can call that function. All right, so first thing to understand is that this function will actually return the rules. Not only will train the Apriori model on the dataset, but also at the same time, this function will indeed train this Apriori model and in the end return the final rules, with the different supports, confidences, and lifts. And therefore, since we're now ready to call this function, and since this function returns the rules, well, let's create a new variable here, which we're simply going to call rules. All right, and that will be the output of that function. And speaking of that function, well, let's call it right now Apriori. That's the function. Therefore, I'm adding some parentheses. And now there we go. Let's see what parameters we have to input. All right, so this function takes as input some very intuitive arguments. We could actually, almost guess all of them. The first one is, of course, well, the dataset. The dataset on which you're going to train your Apriori model. And the name for that parameter is transactions, actually, because the Apriori model is mostly used to compute some correlations and association rules among transactions. So that's actually the name of the parameter. And of course, the value for that parameter must be, well, that same transactions list, which we created in the right format right before this tutorial in the data preprocessing phase. Okay, so this is the name of the parameter, and this is the name of our transactions list, which is the value of indeed that parameter. Okay, good. So that's for the first argument. That was an obvious one. And now, according to you, what would be the next argument? Well, the next argument has to do with the support. Of course, it's not going to be a simple support because we have a support for each rule, but what we can set is actually a minimum support, in order not to compute all the rules, but only the rules that have at least some certain relevance. And therefore, we will set a minimum support value in order to take not all the rules, but only the rules that have a support higher than this minimum support. All right, so let's first enter the name of the parameter here, which is min_support, right? And now, according to you, what should we choose as a minimum support here? Well, this has to do, of course, with our situation, the problem itself. And of course, some common sense. So let's recap. We have in total 7,501 transactions that were recorded over one full week. And among these 7,501 transactions, we want to get the most relevant rules, the strongest rules of two elements, with one element of the left-hand side of the rule, one product, and one element in the right-hand side of the rule, which is another product. And we want, therefore, these products to appear a minimum amount of time. And that's exactly what the support is about. Remember, the support of a couple of products A and B is the number of transactions containing these two products A and B divided by the total number of transactions. So we need to see here, for a couple of products A and B, how many times per week we need to have at least these two products in the transactions. Well, let's use some common sense. Let's say that each day we would like to consider the products that appear in at least 3 transactions in the day. All right, 3 transactions in a day, because all the products that appear in only 1 transaction or 2 transactions, are actually not frequent, and we would not build some strong rules out of these products. So our common sense here is to only consider the products that appear at least 3 times a day. And therefore, since the 7,501 transactions were recorded during the full week, well, we need to multiply this number of 3 transactions per day by 7 in order to get, that minimum number of times we want to see these products in the transactions per week. And therefore, that number of times is 3 times 7 equals 21. And since the support is the number of times the products appear in the transactions divided by the total number of transactions, well, the minimum support, considering that we want to see minimum 3 times per day the product, must be 3 times 7 divided by 7,501. All right, so that's purely based on common sense. You could choose another minimum support, but there you go. That's a minimum support that goes well with our scenario, with our business case study. And therefore, what I'm simply going to do now is just open a new tab here to quickly compute, 3, as in minimum 3 times we want to see the products appear in the transactions per day, then times 7, because the 7,501 transactions are recorded over a week, and therefore, when calculating the support and dividing by the total number of transactions, the numerator and the denominator must be in the same unit of time, which is 1 week, and then divided by 7,501 total transactions. Let's just press enter. We'll get the result, which is 0.0027, and we can round that up to 0.003. And 0.003 will be exactly our minimum support. So I'm going to close this and I'm going to enter here 0.003. Perfect. So that's for our minimum support. Now, the next argument, what do you think it's going to be? Well, you probably guess that this time we're going to choose a minimum confidence, right? A minimum confidence. All right, so this time, what should we set as the minimum confidence? Should we use, again, common sense, or should we try some different values? Well, this time we won't do the same kind of calculation as we did for the support. This time, I'm rather going to give you some rule of thumbs, which you can try when doing association rule learning. So I know from the other packages, the one from R, because there is actually a great function in R to do association rule learning, and it has indeed a default value for the minimum confidence, which is 0.8. So what I actually did, for this problem is to start first with 0.8, but this was way too high because 0.8 would require the rule to be correct 80% of the time, and therefore I ended up with actually no rule. So I had to reduce the confidence, so I divided it by 2. So that I can try a minimum confidence of 0.4, but still I got very few rules, and so I divided it by 2 again, and thus with 0.2 I actually got some great rules. Not too much, not too few, but a dozen of them. So that was a good choice, and that's how I chose this minimum confidence. Therefore, here for this minimum confidence, we will set it equal to 0.2. Okay? Once again, no rule of thumbs, you can try different values depending on your business requirements. All right, then next parameter, I'm sure you guessed it as well. That is this time the minimum lift, that other metric which measures the quality of a rule or the relevance of a rule. And so now, according to you, what would be a good minimum lift? Well, that kind of decision to make, you get them with experience. You will see through the many association rule learning models that you're going to build on your datasets that generally a good lift is at least 3. 3, 4, 5, 6, 7, even 8, 9. These are good lifts. But lifts below 3 make the rules not that relevant. And therefore, this is kind of a rule of thumbs that I'm giving you here. It is not based on common sense, rather based on experience. And therefore, I recommend to choose a minimum lift of 3. All right. And with this minimum lift, we will get good rules, relevant rules. Okay, so minimum lift equals 3. And then we have 2 last arguments that are actually very, very important and in fact compulsory for our business problem. It has to do with the fact that, we want to identify the best deals of buy one product A and get another product B for free. And therefore, the rules we want to get in the end must have only two products. One product in the left-hand side of the rule and one product in the right-hand side of the rule. All right. And therefore, to make sure we have this, one product A on the left and one product B on the right, well, we need to add two more arguments here, which is first min length, okay, and then max length, where, of course, min length is the minimum number of elements you want to have in your rule, left or right, and max length is the maximum number of elements you want to have in your rule, left or right. And therefore here, to make sure we only have two in our rule, one on the left and one on the right, well, obviously we need to set min length to 2 and max length same to 2. And that's only because in our business problem, we want to find these best deals of buying one product A and get one product B for free. And therefore, our rules must have exactly two elements. Then imagine you wanted to find the best deals of buy two products and get a third one for free. Then you would set min length to 3 and max length to 3. And if you want to be very, very flexible on your deals, like, you could have deals with buy one product A and get one product B for free, or buy two products A and get one product B for free, or, buy 10 products and get one for free. Well, in this case, you would set min length to 2 and then max length to 11. Okay, so that really depends on your business requirements, your business problem. Here, we just want to find the best deals of two products, buy one product A, get one product B for free, and that's it. And that's why we set min length to 2 and max length to 2, so that our rule can have only two products. All right, and that's it. Well, we're done with this Apriori function, which will return the rules respecting all these values we set for the parameters, a minimum support of 0.003, which means that the products in the rules appear at least 0.3% of the time. Then a minimum confidence, which means that for each product A in the left-hand side of the rules, well, we will have product B in the right-hand side of the rule at least 20% of the time. And then we have a minimum lift of 3, and we have only two products in our rules, thanks to this min length equals 2 and max length equals 2. All right, so are you ready? Are you ready to run that cell to get the rules? We won't have them displayed in the output, but don't worry, we will visualize them right after this tutorial in the last part. So let's do this. Let's play the cell, and there we go. Now, my friends, we have the rules.